All right, so the way this is going to work is every time I bring up a new test, I am going to go through the checklist with you. So that way you will know that, what conditions you need to satisfy before you should be choosing this particular test. Okay? So we're going to start with the single sample t-test, also called the one sample t-test. And first on this checklist is you have in other words, one sample or group of participants. Now that's important, and I can't tell you how often I see somebody using the single sample t-test when they have two sets of data or two groups that they've collected information on and they're trying to compare two means. Well, that is not a single sample t-test. You have one set of participants, one group of data. Okay? Wish to see, this is the second one, you wish to see if the sample mean, in other words, x bar, is significantly different from some other number. And that other number is called a constant. All right, so you're going to have a collection of numbers that came from a single group of participants. You calculate x bar, and you're going to compare it to a constant, which is some other number. Now, don't worry, I'm going to talk about what that other number might be, and it depends on your research question, but I'm going to show you that. All right. It's important to understand that the constant, that other number that you're going to compare x bar to, is not pulled out of thin air. It's not just some random number. All right. You choose this number based on your research question. All right, there's a reason why you want to compare x bar to this other number. And so you have to make sure the constant is chosen appropriately. Number 3, you are looking for a statistically significant difference between the sample mean that you calculated and that other number that you chose, the constant. All right, or just C for short. Now, SPSS refers to the constant as a test value. All right, it's just another example of SPSS making our lives just a little bit more difficult than it needs to be, but that's what we have to work with. Now, one thing I'm going to stress throughout this chapter and the chapters on ANOVAs is that when we are comparing means or a mean to a constant, or we're comparing 2 means, 3 means, etc., whenever we run a t-test or an ANOVA, we are looking for differences among means, okay, or in this case, a mean to a constant. We are not looking for relationships among scores. Now, you might not yet see that that's something different, all right? So you might be thinking, well, what's the difference between looking for a difference among means versus a relationship among scores? That will be made clear to you later on. But if you could just remember that when we look at means, we are asking questions about differences, not relationships. If we're face to face, I have these, I think they're called Bean Boozle or something, jelly beans that have these awful taste to them. And I tell everybody in the class, anybody who says the R word being this, is going to have to come up to the front of the class and pick out one of the Bean Boozled jelly beans. And you're not allowed to eat anything else afterwards or drink some water when you go back to your seat. It's pretty hilarious. Unfortunately, I end up by accident saying the R word at least once or twice a semester and get bean boozled myself. But it's kind of a fun little game we started up a few years ago. All right, so do not say the R word anywhere through this chapter or the ANOVA chapters. We're going to look at an example of a one sample t-test, but first we need to talk about the hypotheses for a one sample test. And these hypotheses can, the hypotheses and the test themselves can be both non-directional or directional. So we're going to look at non-directional first. So these hypotheses here are non-directional. And remember, if they are non-directional, then you're going to have to run a two-tailed test. In order to use a one-tailed test, your hypotheses must be directional. So again, these are non-directional hypotheses, which means you have to run a two-tailed test. If we look at HO, HO is saying that mu is not going to be is the same as the constant, right? HO, null, none, nothing. So we don't put X bar here because we're interested in the population, not our particular sample. So we replace X bar with mu, and we're just going to say that it's the same as the constant. HA is going to say, no, they're not, they're different. And notice that HA is not saying mu is going to be bigger than the constant or smaller. That would make it a directional hypothesis. Non-directional just means, look, they're going to be different. I don't know how, they're just going to be different. Now, the directional hypotheses, well, there's two of them, right? Because, again, let's start with HA. Remember I said it's easier to figure out HO if you begin with HA. So HA says mu is going to be greater than the constant. So that's one possibility. If that's the case, HO has to say everything else, and everything else would be mu is less than or equal to the constant. So again, one possibility. Another possibility is instead of saying mu is greater than the constant, you could say mu is less than the constant. In this case, HO would say everything else, so it would say greater than or equal to. All right. Now, if your hypotheses are directional, now you have the option of doing either a two-tailed test or a one-tailed test. But just remember, if you're going to do a one-tailed test, it's not enough just to have directional hypotheses. You also have to have the literature to support your hypothesis. And usually that's not an issue.